In this podcast, I'd like to review how to find the terminal points on the unit circle. This is usually a topic, it would be one of the first or second topics that we would study when we're working with the trigonometry of real numbers, either in a trigonometry class or a pre-calculus class, or even an Algebra 2 class. And it sort of assumes that you understand that the equation of a circle is given by x minus h quantity squared plus y minus k quantity squared equals r squared. And on the unit circle, our center, h and k, is at the origin, and our radius is 1, okay? 1 for the unit circle. So we really end up with x squared plus y squared equals 1. And that means that every point, every terminal point or ordered pair on the unit circle must work in that equation. Okay, so if you look at the circle that I have here, the origin is at 0, 0. That's the center. And then 4 easy points to get right away are the ones on the ends, which would be 1, 0, negative 1, 0, 0, 1, and 0, negative 1. Now, that means that all the other points on the unit circle are ones that have to be in between negative 1 and 1. So they're going to be fractions, and in a lot of cases, if we leave them as exact values, they'll also be square roots. Okay, so let's say, for example, we think that we have an ordered pair where the x value is 1/2. Could we find what the y value is using the equation x squared plus y squared equals 1? Yes, we can substitute 1/2 in for x, square it to get 1/4, and then we're going to add that to y squared to equal 1. So if I subtract 1/4 from both sides, y squared equals 3/4. And then if I take the square root, y would equal plus or minus the square root of 3/4, which is the square root of 3 over the square root of 4, or the square root of 3/2. Now, if I change that to a decimal approximation, that is about 87/100. Okay, so according to this equation, the ordered pair 1/2 and either plus or minus the square root of 3 over 2 is going to be on the unit circle. Well, where would that be? Let's say if I'm on the unit circle from in between the origin and 1, let's go to about 1/2. We could either go up or down. That's why we have a plus or minus. And we're going to end up with a point on the unit circle with the values 1/2 and square root of 3 over 2, or 1/2 negative square root of 3 over 2. And in fact, that is going to be the point right here. We'll talk about why that is even more in detail in just a little bit. And this one would be 1/2 negative square root of 3 over 2. Okay, now, all right, I've got another blank unit circle here, but I'd like to talk about how you find the middle values. So what would be the ordered pair right here that corresponds with a radian measure of pi/4? Okay, so first of all, if I were to drop down a triangle and create a 90-degree angle in here, this triangle would have a 45, 45, 90-degree angle proportions. And if you remember your geometry, you learned that a 45, 45, 90 triangle, the side lengths are proportionate by 1, 1, and the square root of 2. Okay, so let's say that this side was 10, this would also be 10, and this would be 10 times the square root of 2. So if you follow that proportion, you can multiply by a number or divide by a number. As long as you do it to all three sides, the proportion will remain true. Okay, so if I have this 45, 45, 90 triangle with side lengths of 1, 1, square root of 2, that wouldn't fit on my unit circle because on the unit circle, my hypotenuse length is equal to 1. So somehow I've got to make this correct proportion for a 45, 45, 90 triangle to fit in the unit circle. And rather than multiply it by a number, I'm going to divide each side length by the square root of 2. Okay, now that might seem kind of weird, but the square root of 2 divided by the square root of 2 makes 1. And then our two side lengths, 1 divided by the square root of 2 doesn't work out nice, but if you rationalize it, you get the square root of 2 over 2, which is approximately 71 hundredths. Okay, do you think if this is 0 and that's 1, that this looks like it could be about 71 hundredths? Hopefully you'd say that's yes. So that means that the ordered pair right in the middle of quadrant 1 is the square root of 2 over 2, square root of 2 over 2. Did we get a fraction smaller than 1? Yes. Did we get square roots? Yeah. Now, once you know that one, you can go over to quadrant 2, and this is going to be the same distance, except the x value should be negative, because we're going left instead of right. And that's why the unit circle has so much symmetry to it. It teaches us all about the symmetry of trigonometry. In quadrant 3, we've got negatives for all of our ordered pairs. So I have negative square root of 2 over 2, negative square root of 2 over 2. And then in quadrant 4, I've got a positive and a negative. All right, so once you understand quadrant 1, you can find quadrant 2, 3, and 4 for the terminal points. Okay, next I'd like to look at the other two triangles in there. One of them is here, and the other one is there. Now these are not going to correspond to 45, 45, 90s. They're going to correspond to 30, 60, 90s. Okay. I don't know why that's there. All right. Okay, so in this triangle right here, I've got a 30, 60, 90 proportion. And if you remember your geometry, 30, 60, 90 triangles follow the proportion of 1, 2, square root of 3. Okay, so again, if you have a bigger triangle, you could go through and multiply all these side lengths by that number. Or if you have a smaller triangle, you could divide it out, which is what we have in this case. In the unit circle, our hypotenuse length should be 1. So we divide everything by 2. And we get an x value in this triangle is the square root of 3 over 2 and a y value of 1/2. Okay, so from there, if we go straight across to 5 pi over 6, we've got negative square root of 3 over 2 1/2. In quadrant 3 at 7 pi over 6, we get negative square root of 3 over 2 negative 1/2. And then in quadrant 4, we get positive square root of 3 over 2 negative 1/2. Okay, now we're almost done. If we were to look at this triangle way up here, drop down that 90-degree angle, it's really the same triangle, but it's oriented different. The inside angle is 60, and then the little one up on the top is 30. So that means that our x value on the bottom is going to be 1/2, but the y value is the square root of 3 over 2. And I had mentioned this earlier, that this is approximately 87 hundredths. So if you look at this distance between 0 and 1 right here is 87 hundredths. Same as up here, 87 hundredths. And then the y value is 1/2, or in this case it'd be negative 1/2. Okay, negative 1/2 square root of 3 over 2. Negative 1/2 negative square root of 3 over 2, and positive 1/2, oops, negative square root of 3 over 2. Okay, if you put it all together, that's what we get. And you can find a unit circle like this on the internet in so many places. Just type in unit circle and you can find completed ones or blank ones and so on. So this unit circle has it's color coded, which is kind of nice, so that you can see the patterns of the reference numbers that are directly across from each other. And you can also see the radian values. Now, I usually tell my students that they need to, I wouldn't necessarily say memorize where all of these values are, but at least be able to figure them out. And so one little pattern here is that all the values on the unit circle come from 0, 1, 2, 3, 4. And if I take each one of these and divide by 2, and then square root my numerator, and simplify. Square root of 0 divided by 2 is 0. Square root of 1/2, that's just 1/2. Square root of 2 over 2 and square root of 3 over 2 don't really simplify any further, but the last one, square root of 4 over 2, would be 2/2, which makes 1. And if you think of the decimal approximates, 7/10, 9/10, let's say you pick any point on the unit circle, drop it down, drop it across. What does that look like? Does it look like 0, -1/2, -7/10, -9/10, or -1? Well, it looks like -7/10. And if you can remember that that corresponds with square root of 2 over 2, and you can figure out what the signs are, then you know what your terminal point. Okay. So the next thing that you would probably learn from this would be how to find sine, cosine, and tangent of the pi values, the real numbers, the radian measures, and how to use the unit circle to find those trigonometric values. So that's coming up in the next podcast. Thank you for listening.